Hi, I'm Trent Radding, and this is a lesson on the law of sines. If there are ever any unknown angles or sides to a triangle, then they can be found using the law of sines. It's A over the sine of A, and then it equals B over the sine of B equals C over the sine of C. Note that all these top values are lengths, and all these bottom values of A, B, and C are all angles. The law of sines can only be used if you're given a particular set of angles and sides. There are only three combinations that will work. The first of these combinations is called angle-angle side, or ASA. I made a little example right here with 98 degrees, 5 length, and another angle down there with 45. The first step is to find the missing angle by adding together the angles from A and C, the first two, and then subtracting them from 180. And so I did that, and I found 37, which is my other angle. Now what I can do is utilize the law of sines by plugging in the B length and the B angle into the equation. So I have that, and I have that, and I plug those both into the equation along with the others, and since those are both the same, I can go ahead and make that my constant value. I go ahead and find that, and I plug that constant value in to solve for all the others since they're all equal to each other. I solve for A and I solve for C just by setting them equal to that 8.3 value. So now the next combination is called AAS, or angle-angle side. You're going to have two angles next to each other, then one side. Once again, you begin by solving for the missing angle. As I did here, you found that I added those two together, subtracted from 180, and found 46. Now what I can do is plug the values into the law of sines and then solve for the missing ones. And so what I did is I found all these I took those numbers, and the 10 and the sine of 30 were both the same, or were both unvariabled, so I found those first and made that my constant value. And then I solved for the A and solved for the B using that constant, setting it equal to that constant value, then finding that. So that is angle-angle side. Now the final combination is called side-side angle, or SSA. It's also called the ambiguous case. Now I'm given a side of 12 and a side of 10 and an angle of 30. Now what I don't know is what this angle is. So for all I know, this angle could be all the way over here. And I'm actually going to do a small example of it right now. So it could really, this 10 could be over there for all we know. So what we're going to do is we're going to find all the values of these other lengths. So we're going to make this B2, and like that's 10. This length down here in the corner is going to be C2. Erase that line, that imaginary line there. So yeah, that's C2. And now this length at the top that goes all the way across, that is going to be B2. And now, so what I'm going to do first is find the largest of the I'm going to solve for the big triangle. I'm going to use the law of sines. I'm going to plug in what I know, and what both of those values are the A value, the 10 and the 30, and I found my constant value of 20. And now I'm going to use that and able to find all the other variables. In this case, it was C. I'm trying to find the angle of C, so I'm going to bring that down. I'm going to do SOHCAHTOA with that and find my C angle value. Now, the next thing I have to do is find my B value. So what I'm going to do is I'm going to take the C, I'm going to plug it in to the formula, and I'm going to subtract all those from 180 and find my missing angle there. And after that, I'm going to be able to plug that into the law of sines and find what the actual B length is over there. So that kind of segues us into the other triangle, which is our isosceles triangle that we created up there. And basically that 36 we have in the corner is also going to be right there since the isosceles triangle. And we know that that top, later on we'll come back to that top angle is just the minus 180. So we're able to here take the, since that carries over, we're able to find the supplement of that and plug that into our knowns. We know that this is 30 degrees from up there, and we know that this is 12 and that that is 10 right there. So that kind of carries us into finding the smaller of the two triangles. We're going to plug those all into the law of sines. What I have both of are the a values, so I'm going to go ahead and solve for a. And what I find as a constant value is 20 once again, and I'm going to make that and use that constant value in order to find b, and b equals 2.39. What I also did there was before I had done that, is find the angle value of b by subtracting from 180. Now, after this lesson, the key things that you should have learned are the law of sines formula, the three situations in which you can use the formula, AAS, SA, and SSA, and how you can find both solutions for the SSA ambiguous case. Thanks for watching this, and this concludes the note.